All right, welcome to The Explainer. Today, we're unpacking a really fascinating and honestly pretty urgent argument laid out by astrophysicist Neil deGrasse Tyson. We're going to explore what he describes as the quiet, systemic erosion of America's scientific foundation. It's a story about innovation, shifting global power, and the unseen engine that ultimately drives our health, wealth, and security. We've got a lot of incredible history and data to cover, so let's just get right into it.
Let's start by jumping right in with a pretty provocative question, one that sits at the very heart of the data we're about to explore. Is the United States quietly losing its status as the scientific capital of the world? For decades, that thought seemed completely unthinkable. But there's a fundamental shift happening right under our noses, and it's completely changing the landscape of global innovation.
Section 1. The Great Brain Drain.
So, to really understand where we're going, we kind of need to look back at the 1980s. Back then, when Tyson was getting his PhD, the physical sciences in America completely led the world. Up to half of his fellow graduate students were foreign-born nationals. The U.S. system just effortlessly absorbed this incredible talent. These students came, they got their degrees, they found jobs, and they stayed. It was a massive brain drain from the rest of the world directly into America. But flash forward and contrast that with today's reality. Take China, for example. The first generation of Chinese students came to the U.S. and stayed. The second generation came, trained, and then went back to build their own programs. And today, the third generation of Chinese graduate students aren't coming to America at all. They are being trained in a rapidly ascending China and staying right there. Meanwhile, you've got fully funded European countries literally calling up underfunded American researchers and actively poaching entire labs. The tables have completely reversed.
Moving on to Section 2, the power of curiosity. Okay, so why does this talent loss actually matter? To understand the stakes, we have to look at what curiosity-driven research actually provides. It's really easy to think, well, we can just rely on big corporations to do our science. But Tyson argues there is a massive difference between corporate R&D and true frontier science. If you're an engineer in corporate R&D, your whole goal is to make a product that shows up as revenue in a quarterly report, right? But frontier science? It doesn't have an obvious pathway to revenue. It operates on decadal or even centennial timelines. Think about quantum physics in the 1920s. Scientists were just wondering what atoms and molecules were doing. Absolutely nobody was thinking about building a smartphone. Yet it took decades of that foundational physics before we figured out how to create and store the digital information that powers your entire life today.
Here's a wild example of how purely curiosity-driven research leads to things we couldn't possibly imagine. You have scientists who just decided they wanted to research the venom of the Gila monster, literally a giant desert lizard. On paper, it sounds completely irrelevant to human health, but that unpredictable frontier discovery ultimately laid the foundational research for the blockbuster GLP-1 weight loss medications that are completely dominating the news right now. You just cannot predetermine what role curiosity-driven research is going to play in your future economy or health.
Or, let's map out another crazy journey. Tyson talks about his own college physics professor, Ed Purcell. Purcell was a physicist who was deeply, deeply interested in atoms and molecules out in space. He had absolutely zero interest in medicine. Well, he wins a Nobel Prize for discovering a physics phenomenon called nuclear magnetic resonance. Sometime later, medical technologists are looking at that and they realize, hey, if you can distinguish atomic nuclei, you could actually make images of human soft tissue in a way X-rays can't. And boom, the MRI machine is born. Arguably the most potent diagnostic tool in modern medicine came from a physicist trying to figure out atoms in space. That is the awe-inspiring power of a moving scientific frontier.
Which brings us to Section 3, America's Scientific Slide. So we're transitioning into our current descent, looking at the evaporation of the funding and the personnel that actually make those unpredictable, world-changing discoveries possible. And the crucial point is grounded in this one stark number, 15,000. According to Tyson's data, over 15,000 scientists have been lost from the ranks of the federal government in just the last 2 years alone. On top of that, grant money from major government funding agencies has been significantly slashed.
And we really need to look at who exactly is getting hit by these cuts. Take postdocs, for instance. These are brilliant researchers who already have their PhDs, they're bursting with energy and creativity, and they dedicate several years purely to grinding in a lab before they become professors. But when the grant money shrinks, the person running the university lab simply doesn't have the cash to pay for postdocs. Without them, the lab literally cannot sustain itself. It just evaporates. And when entire hubs of intellectual capital vanish like that, the pipeline for the next MRI machine or the next revolutionary drug evaporates right along with them.
And you can see the symptoms of this slide everywhere. We're seeing shrinking government grants for unpredictable research, a lot of times simply because a paper's title sounds quote-unquote irrelevant to a budget committee. We're also seeing the elimination of rotating academic advisory roles. It used to be that scientists would do tours of duty advising the Justice Department or the White House, but a lot of those positions, they just don't exist anymore. Tyson points out that cutting this stuff might look like a savvy cost-saving measure on a spreadsheet, but it is actually severing the nation's future health, wealth, and security right at the kneecaps.
Tyson uses a really powerful metaphor here, and it's absolutely crucial to understand. He says this is a slide. It's not a cliff. Think about it. If you fall off a cliff, it is obvious, it's sudden, and you notice it immediately. But a slide is gradual. As scientists get cherry-picked by other nations, as labs dry up, as older scientists retire and just aren't replaced, this intellectual vacuum descends quietly upon the country without setting off any immediate alarm bells.
Section 4. The Unifying Crisis. So as the U.S. descends further down this slide, what actually forces fractured political factions to stop bickering and look up? Well, Tyson shares this fascinating little anecdote. Remember those recent congressional hearings about aliens and reverse engineering spacecraft? What really stood out wasn't just the subject matter, but the behavior in the room. You had both political parties sitting right next to each other, practically hand in hand, asking common questions. It literally took the prospect of aliens to completely unify them. And this perfectly echoes a famous prediction Ronald Reagan made back in a 1987 speech to the UN, where he mused about how quickly our worldly differences would just vanish if we faced an alien threat. It just proves that a common fascination or a common threat can instantly bridge our divides.
Now, here's a vital distinction to make. Funding is, for sure, political. Political policies completely dictate what science gets supported. But the discoveries themselves, those are not political at all. Science moving on the frontier is apolitical because it comes directly out of nature. And nature really doesn't care about our factions. It is the ultimate judge, jury, and executioner of what actually happens in the laboratory.
Section 5. Rocketing out of the hole. Even though we might be sliding right now, there's a really inspiring historical reality we can draw on. The U.S. has successfully rocketed out of deep holes before. Let's look at October 1957. The Soviet Union launches Sputnik. It was a total existential shock. An enemy transmitter flying over American heads, implying a nuclear payload could easily be next. The nation was totally spooked. But look at the reaction. Within 1 year, NASA is created. Within 11 years, the U.S. orbits the moon. And within just 12 years, Americans are walking on the moon. The nation rocketed out of that hole because they were properly motivated.
We see the exact same kind of mobilization right here. In 1940, the element plutonium is isolated. December 1941, the attack on Pearl Harbor happens. And suddenly, boom, absolute unification of resources. Scientists, the military, the corporate world, everyone pulled together. Just 5 years later, the first atomic weapon was detonated at the Trinity site. Think about that. Today, it can take 10 years just to build a bridge. But history provides the hard evidence. When motivated as one nation, understanding the goal and the investments required, incredible things happen at lightning speed.
So let's wrap up this explainer by leaving you with a really critical question to chew on regarding the future of global innovation. Will it take another major crisis to reverse this current quiet slide and unify the country's scientific ambitions? Or can we recognize the evaporation of our intellectual capital before we actually hit the bottom of the hole? The science is going to keep moving forward regardless of who leads it. The question really is just who's going to be doing the leading. Thank you so much for joining me as we explored this today. Keep questioning, keep learning, and I'll see you next time.